Hmm. Hmm. नहीं नहीं, it's streaming. अभी हुआ है, जस्ट अभी हुआ है. It's been 10 seconds. Namaste everyone. Sorry about the previous disturbance. Welcome everyone to Industrial Wastewater Treatment webinar. I am Dr. Rimzhim Gupta. I'll be the speaker for today's webinar. I am a research scientist at Paanduv Applications. In today's webinar, we will touch upon different aspects of industrial wastewater treatment processes. We will discuss in more detail about each and every unit operations that are used in primary treatment, secondary treatment, and tertiary treatment. We will also look upon various computational modeling methodologies which are going to impact wastewater treatment industry, and how with the use of computational modeling and AI you can create a robust framework for your wastewater treatment industry, and how Pandav can help you in that. I think you must have seen some of these images from your surroundings. These images, and if we think about retrospect, who is responsible for these scenarios? The answer is that we are responsible for such scenarios. Let's take it upon the social responsibility that we have and think about it. The third image that you see here, in which the marine life is completely affected, this can happen due to major oil spills, the existence of various contaminants in water, the disbalance between pH and abundance of the scarcity of light, a scarcity of dissolved oxygen in water. The marine life is getting harshly affected. But if we think about other images, some of these images are images that we have taken from the source where the water bodies are generated, that means the glaciers. When the human penetration is start happening and access to places is happening, we are responsible for such scenarios and making the water dirty from the source itself. So we have to take it upon ourselves to be responsible enough to at least do our bit, and hence the sustainability will follow. Now, with another thought, if we think about access to clean water, there was a recent report by UNESCO in 2023 in the Water Conference, which revealed that 26% of global population lacks safe and drinking water, while 46% do not even have the access to well-managed sanitation facility. This is a big question if we think about it, that the clean water is a basic right of every humankind, and if we don't have that, what do we have? With that thought, I would like to introduce the company that I am associated with, and I would like to tell you how Paanduv Applications is making contributions in the previous questions that we asked. Paanduv Applications is a cutting edge technology company. We operate in computational physics and AI domains. We hold expertise in custom software development services, custom simulation software development services, and consulting services. We apart from water and environmental, we operate in cutting edge industries which are responsible for increasing the carbon emissions, and they are highly responsible to deviating from the sustainability scenario that we have. So additive manufacturing, data centers, chemical industry, oil and gas, these are some of these technologies or industry that we operate in. And broadly speaking, we hold expertise in simulation software development, consulting services that we provide to industry. We also collaborate highly with academic industries, academic institutions for collaborations on their projects. We also provide custom trainings to students for their projects if they want to learn some specific things. We help them in knowing and training them on those aspects. Also, we invite students to join us in our campus to work upon real-time industrial projects, which is kind of very interesting for them. And we also invite students for this fall to join us for internships. Overview on the water industry, kind of water that we deal with. Then I will talk about the unit operation and technologies which are highly used in water treatment industry. We will talk about the classification of contaminants and the processes which are specific to different contaminants. We will understand the concept of zero liquid discharge and circular economy, which is zero liquid discharge is applicable to all industries. In fact, circular economy concept is also applicable to all industries. We will then talk about the reliance of computational physics and AI and how water treatment industry is highly reliant on that. And in the last, I will tell you how Paanduv applications can help you in all of those aspects. What is our value proposition? Let's start with the overview. First of all, what is a water footprint? When the water is consumed, the tracing of that, and if we trace how the water is being used, that is called the water footprint. And on broad category, we can divide it in three forms: green water footprint, blue water footprint, and gray water footprint. Green water footprint comes from the source, which is precipitation. The water percolates through soil, it evaporates, it transpirates through agriculture and horticulture applications. Blue water is something that comes from the surface water, different water bodies, and groundwater. We take that water, convert it into a product, or use it in domestic purposes or industrial purposes or irrigation purposes in agriculture. So that is blue water footprint. Gray water footprint is something that is the polluted water, which comes from the industrial waste. That kind of water we categorize into gray water footprint. Now, if we talk about the statistics that we have currently in India, total sewage generation is about 72,368 million liters per day. The installed capacity is around 31,841 MLD, and operational treatment is only 26,869 MLD. That means there is a huge gap between our operational capacity and the total sewage generation. So this gap needs to be filled rapidly. But there is a good sign. From FY 2017 to FY 2022, there is a significant increase in the access of safe and adequate drinking water within the premises of India. The numbers increased from 36.52% to 61.52%. This is a data that we have taken from Ministry of Jal Shakti. This data indicates that it's a positive sign, and we still have a long way to go. Now, broadly speaking, when the water comes from the cities, it goes to the wastewater treatment plant. The water separates from the sludge. The sludge goes to the sludge treatment plant, and the water is available for reuse, or it goes to the secondary and tertiary treatment plants for potable water purposes. On the right hand side, I have a flow diagram which indicates when the water generates from, when the raw sewage generates, it goes through some of the bar racks, grid chambers, and equalization basin, which is the pre-treatment phase, where the macroscopic impurities are eliminated. Now the remaining water goes for the primary treatment, which accounts for aeration, centrifugation, clarification, gravity sedimentation, etc. where the primary treatment happens. Next, water goes to the secondary treatment phase, where hardening is eliminated, the water is softened, the chlorination happens, and further for advanced processing or for making the water potable, it goes to the advanced waste treatment plant, which is a tertiary treatment, wherein photocatalysis, UV treatment, or different methodologies are used to make the water drinkable. Let's understand this thing into much deeper now. Let's say we are generating a domestic waste. What are the sources of dirty water in a domestic household? The one is kitchen and the second is sewage. The dirty water can be created by these two sources. In kitchen waste, you have a lot of oil, grease, and grit. Then in sewage, you have different kind of excretion material that you want to eliminate. So in both the cases, the water goes through first from the bar screen chamber. That means your macroscopic impurities will be removed from that. It goes to the equalization tank after that. Equalization tank acts as a buffer tank which holds the amount, a good volume of water in that tank, and then it starts sending out that water for further treatment. So now from equalization tank, it goes for the primary treatment. Aeration tank, aerobic reactor, these are used, these provide a certain amount of oxygen through diffusers, which allows the growth of microbial moieties into the chamber. These microbial entities will eat up all your organic waste, and organic impurities will be decomposed and it will convert into the sludge form. This sludge will sediment down in these through these clarifier. This is a gravity sedimentation process. Through these processes, your water is separated out and your sludge goes to the sludge treatment plant, where it is conditioned and dewatered and dried up, and it is disposed of. The water goes back to the equalization tank. You can see all these arrows will indicate how the flow of water and sludge is happening. So finally, when the water comes from the clarifier 2, the sludge is sent to the dewatering system, but the water is sent to the sand and carbon filters, where multiple impurities are removed. Now from here, the water will go for secondary treatment, and after that the water will go for the tertiary treatment. In secondary treatment, there are some offensive ions such as calcium ion, magnesium ion, iron. These ions are removed, which act as the inhibitors for further processing of water. So these needs to be removed efficiently. So first water is softened, then it is sent for the chlorination. Now this chlorination chamber is very, very important. This is basically a serpentine channel through which the water is flowing. Now in this chlorination chamber, lot of reactions are going on, and modeling these reactions is a big question, because you need a separate expertise to model such systems. These are complex systems, and there has been a good amount of literature where these all reaction kinetics are listed. So you can refer those literature to get the reaction kinetics. Now from chlorination, you give a certain amount of dosage for chlorination. The byproducts generated through this process are carcinogenic, and these are harmful byproducts. Therefore, these byproducts needs to be converted into something which is less harmful. Therefore, this process is very, very important to model, and it requires an special attention to model this system. Now the water is ready for reuse. It can be used for toilet, flush, gardening, etc. Now, if you want to make the water potable, you have to do advanced treatment, that is tertiary treatment. You have to pass it through RO filtration systems. You have to pass it, or you can treat it using photocatalysis, Fenton system, or UV systems, which are highly referred at the later stage of the treatment plant. Now, if we look upon the treatment line, we can categorize this in three major chunks. One is mechanical cleaning, sludge treatment, and the biological cleaning. In mechanical cleaning, you eliminate the macroscopic impurities such as sand, gravels, grit, oil, etc. Then the water, the impurities go to the sludge treatment methodology and sludge treatment line. The water goes to the biological cleaning, where aeration happens, and coagulation, chemical treatments through flocculation and coagulation. Your impurities settle down, and then through clarifiers you can eliminate that impurity. Now, the water can be sent for the secondary treatment or tertiary treatment, but the sludge from here goes to the sludge treatment plant. Through primary treatment, you can eliminate up to 60% solids, and BOD can come up to 35%. Through secondary treatment, solid removal can be up to 85%, and the BOD can come up to 85%. For advanced treatment, solid removal is around 95+%, and you are eliminating the existence of nitrogen species, you are eliminating the phosphorus species, etc. Now, let's talk about the unit operation and technologies that are used in industrial wastewater treatment. Wastewater treatment, the first one is removal of oil. There have been many cases where oil spills have been seen in the ocean water, and that has impacted the marine life in a harshest form. So, there are methodologies like oil skimmers or mechanical separators which can eliminate the existence of oil on the water surface. Oil skimmers is a floating device which sucks the oil and air which is at the surface. It sucks it and it goes to the external circuit where you have the scraper. You scrape the conveyor belt, and then in this way, through this rotary motion, the oil is eliminated and the water comes back to the source. Now, this is another kind of system that is modeled here, which is the drum skimmer. This drum has a conveyor belt which, due to its surface properties, it absorbs the oil, and through the scraper the oil is removed and the water comes back to the original system. So, in this particular computational domain, you can see at the right hand side there is inlet, at the left hand side there is outlet, and a periodic boundary condition is provided so that the water which is going out comes back through inlet. The top surfaces are all given the atmospheric condition, and all the walls are no slip boundary conditions, and the authors have imposed a VOF multiphase modeling where you can track the interface between oil and water and air. This is a three-phase system, and with time you see when the time starts at 1 second to 45 seconds, the red color surface, which is the oil, is reducing completely at 45 seconds. So you can predict that how efficient your drum skimmer will be with the help of computational modeling, and in how much time you can recover the oil from the water. Now, you can vary certain parameters here. You can vary the drum rotational speed. You can predict the oil content at different heights. You can make it bigger. You can increase the dia, etc. And those all design parameters, those all operational parameters can be deduced by computational modeling efficiently. The second example is mechanical separator, which is mostly used in petroleum industry. This is as a primary step when the crude oil comes from the pipeline, and you have the water along with crude oil. How you want to remove that? In those cases, in industrial cases, mechanical separators such as this one is used, and here the location of this baffle plays an important role in deciding the separation efficiency of the oil and water. This is a three-phase system that we have modeled: oil, water, and air. And in the three cross sections, you can see that with the positioning of this baffle, you can adjust the separation efficiency of the overall system. Now coming on to the primary treatment section, which is the clarifier, where the settling velocity of these systems become very important. And up to what we were modeling, we were taking water as Newtonian fluids, but in this case, particularly this case, when you have a lot of impurities and sludge in water, the viscosity changes with change in shear rate. So your system becomes non-Newtonian. In those cases, you have to apply the appropriate models. For non-Newtonian models, you can use power law model, or you can use Herschel-Bulkley rheological model, which is highly used. In this particular case, you see that there is an inflow, there is a recycled flow, and there is overflow. And with certain settling velocity, you can separate the solid, because this is gravity sedimentation. So solid will suspend down, and then it can be removed easily. And here velocity, total suspended solid, all of those concentrations are plotted. If you want to go much deeper into this case study, I have provided the link, and you can refer this case study for your particular case. Now coming on to the primary treatment part itself, but more on the advanced unit operations, which is a moving bed biofilm reactor. In this particular reactor, you have these diffusers from where the oxygen will come out, and these have this biomedia. This biomedia will help nutrients to grow faster, and this biomedia will allow that to happen, and it will eventually settle down, and it can be removed further. The sludge will be removed further, and you will have the cleaner water at the end of the cycle. So this is kind of the aeration chamber that we were talking about earlier. So now moving bed biofilm reactor will have a higher efficiency than the previous one. Even if there is a disturbance in pH, you actually, because these biomedia is having different layers of biofilms. So eventually, if there is a pH modification, the first layer eliminates. Even then, you have a good enough amount of separation efficiency associated with this process. Now let's talk about another efficient process, which is membrane biological reactor. This biological reactor can completely eliminate the option of clarifier. It can also eliminate the complete effect of aeration tank and clarifier, and you can use just the membrane biological reactor. This biological reactor has different sheets of membranes from where the water and oxygen will come through. Due to the continuous upward flow, the fouling is also very limited here, and it will remove the solids from the water, and finally the sludge is eliminated, and you have your cleaner water which is ready for reuse. Now coming on to the sequential batch reactor, it is associated with, it completely eliminates the cycle from equalization tank. Let's say you have this equalization tank which is operated in batch reactor form. It is not a continuous process. So once the equalization chamber is filled, this water is pumped in the another chamber where the sediments are already removed. Now here the oxygen will be diffused through, and due to some chemical dosing, your flocculation will start happening. Due to the flocculation, the gravity sedimentation will improve, and then you can have your clean water recycled, taken through the pump in the another chamber. So this process operates in batch reactor form. Now coming on to the integral part of wastewater industry, which is the chlorinated contact tank, which is also called CCT. These are basically the serpentine channels. There are two aspects of modeling here. First one, if you want to know the dead zones in this particular channel and you want to see whether your flow is effective or not. In those cases, you can have your single phase modeling, scalar transport modeling. You use a non-reactive tracer and you just follow its path. You just take how it is flowing in this particular channel, and you can deduce the dead zones through that, and then you can incorporate some internals through which you can improve the overall flow of the system. Another aspect of this particular problem is multi-phase modeling. You have different you have different species in the system. You have air on the top, and you want to model the multi-phase modeling system, which is more complex than a single phase modeling system. Another complexity can be added by incorporation of the reactions, because this system itself is a complex system. You have tons of moieties, tons of impurities here. You have impurities in nitrates form, you have impurities in ammonia form, and you have impurities in bromate form. So all of those impurities react differently with water and with chlorine, and through that chlorination process, it will generate different byproducts, and those byproducts can be really, really harmful. So one has to identify which byproduct needs to be suppressed. So this is the heart of the overall wastewater treatment system. In this particular case, we have modeled 5 reactions, which is chlorine hydrolysis, through which the chlorine converts into hypochlorite. The second is disinfection reaction, when the hypochlorite acts with the organic microbial concentration. Ammonia removal, dichloroamine and trichloroamine formation. Now, if you see these 3 reactions, the product from first reaction acts as the reactant for second reaction. The product from second reaction acts as the reactant for third reaction. So these are the sequential reactions. And the steps which are followed here is chlorine consumption, second is disinfection, and third is formation of disinfectant byproducts. So there are 8 species in this system, and you can see the species concentration distribution in in this particular plot. You will see that when reactants are being consumed during a process, the concentration reduces, and when the products are formed, the concentration increases when it goes from entrance to exit. There can be many analogous systems, such as algal cultivation cultivation in raceway pond, where you provide a certain amount of nutrients for algae to grow, and you want to optimize the growth of algae. But that is completely different application. Now coming on to the closed system, which is the bioreactor systems or photocatalytic reactor systems, wherein the topology of the internal surface of the reactor plays a very important role, and that's what we wanted to understand through this study. Here is a reactor with certain outer dia and certain inner dia. The internal surface topology was changed from flat to positive skewed surface and then negatively skewed surface, and we wanted to see if the biofilm forms in this particular reactor which will be uh, which will be the advantageous surface, and where the shear stress will be high, where the shear stress will be low. So all of those aspects we wanted to understand, and through this particular image you can see that corresponding to positive skewed surface, the shear stress is much higher compared to when the surface is negatively skewed. So in this form you can make minor modifications in your reactor, but you can get the higher efficiencies in your overall process. Now coming on to the another integral part of wastewater industry, which is the ozone contact tank. This is also very important because ozone itself is a oxidizing moiety which helps oxidize the impurities present in water. Now there are different challenges here. The first one comes with the flow of the overall process, but the major challenge in ozonation tank comes with the retention time of ozone in water, because if you give larger bubbles to the system, due to buoyancy it will rise above and go at the surface and collapse. You have very low retention time in those cases. But if you reduce the bubble size up to 100 to 200 nanometer, you can increase the retention time of these bubbles. This will exist in the system for longer, and it will interact with the impurity in a much efficient manner. When the bubble size reduces up to 100 nanometer, the Brownian motion uh, takes charge, which is the dominant force, and due to which it starts the zigzag motion inside the domain itself. That's why you must have seen that for ozonation processes, the tank height is generally larger because they want to retain the bubbles in the tank for as much as long possible. In this particular case study, the authors have modeled a single phase flow as well as a multi phase flow uh, using the Eulerian approach. Uh, Single phase flow will eventually give you where the dead zones are, if the flow is efficient or not. But they have also modeled a set of reactions which are happening in this particular ozone contact tank. Ozone self decay is one process through which which is the primary step. And then when ozone reacts with organic content, ozone reacts with the bromide, hypobromide, bromite and bromate species, and what are the associated reaction kinetics to that. If you impose this to the system although becomes more complex, but you can gather more information through the modeling practice. Now coming on to much larger systems that we talk about. Earlier we were talking about the industrial scale systems, but now this is much large scale system. This is happening. This system is there is a river nearby Bareilly, where the Paanduv office is located. Gola River is the river name, and over the period of time, the river has changed its path. It has meandered significantly, and due to the highly populated areas nearby, and due to all those reasons, the meandering has happened significantly. Now there is a bridge in this particular region from where the river goes in tangential manner, and it is affecting the structural integrity of the bridge. Now there was a channeling there was a channel created in the original path of the river, through which it is expected that it will eventually change its path to the original path. So through which you can see that in nearby regions to the bridge, the velocities are quite high in this particular region, but when the channeling started happening, the velocity, the high velocity regions could be controlled in this manner. So not only computational modeling is used for studying the existing system, but you can create a case study, you can create some preventive measures and understand how the catastrophe will affect the downstream. All of those aspects can be understood well by computational modeling. This is another example, real-time example. This is a Red Chris mine located in, I think, in Canada. And we wanted to understand that what happens if the dam fails. So we artificially, through computational modeling, broke the dam, and we wanted to see what will be the downstream flows, how the downstream areas will be affected. So this is the Red Chris mine, and it originates. It actually produces a lot of gold slurry, gold waste, and we compared gold slurry flow with water. Gold slurry flow is taken as non-Newtonian flow and water as Newtonian flow, and the difference in kinetic energy will give you an indication that okay, yeah, the catastrophe caused by the non-Newtonian gold slurry will be higher than the water. So accordingly, the habitat can be planned in that way. Now, coming on to some smaller mixing systems that are highly used in wastewater treatment industry. This one is oil and water system. Mixing of oil and water is very crucial. For that, you need to use special and different impeller designs, and here we are using three impellers, and all three are different. So and angular arrangement is also very different. So these systems become complex when you have the dynamic meshing or AMI incorporated into these systems. This is the second one, which is the static mixer, which are usually used to mix two species, or one is Newtonian, one is non-Newtonian. Something such systems can also be used for mixing through static mixer. This is a standard Kenix mixer where you don't have the mechanical uh, rotating machinery, but these are static elements which impose certain pressure on the fluid to mix it together. Now coming on to the classification of contaminants. Broadly speaking, we can categorize all the contaminants in four forms. First one is macroscopic pollutants, inorganic compounds, organic compounds, and pathogens. In macroscopic pollutants, you have metal, big blocks of metal, or small blocks of metal, plastics, paper. In inorganic compounds, you have electrolytes, nitrites, sulfates. Organic compounds, you have phenols, pesticides, and nitrogen compounds. And for pathogens, you have bacteria, viruses, and parasites. And for all of these separate uh, contaminants, you have different uh, treatment processes. For example, macroscopic pollutants can be eliminated easily by the use of screening or mechanical separation techniques, followed by, if you have the waste coming from any petroleum industry, textile industry, or any other industry, the methods will be completely different. Do you have turbidity in your system? Do you have more of the order in your system? So accordingly, your treatment methods change. uh, Now, in organic compounds, you have mostly electrolytes which have high polarity, and to remove those kind of ions and impurities, polar impurities, one uses ion exchange methods which are highly efficient uh, for such impurities. Organic compounds such as phenols, pesticides, and nitrogen containing compounds can be eliminated using solvent extraction method, where based on the polarity, the miscibility changes, miscibility of the or solubility of the impurities change, and they leave one phase, goes to the another phase, and then that phase can be separated out. Similarly, phenol pesticides can also be removed by photocatalysis, ozonation process, Fenton process. although photocatalysis process is not yet in mature form to be used in the industrial processes, but it is getting that attention, it is getting that there are still challenges for it to be used at commercial scale. Bacteria, virus, pesticides are usually eliminated by chlorination, UV process, ozonation process, or photocatalysis process. Photocatalysis is uh, highly efficient. UV is also used in wide manner to in tertiary treatment processes. Now let's understand the concept of zero liquid discharge and circular economy, which is very important in current scenario in when we are leading towards getting more and more sustainable solutions. Uh, if we have any industry, let's say textile industry or any manufacturing industry, the water which is used there, the fresh water which is being used, and the contaminated water which is generated through the processes, it should not go out. The contaminated water should be treated again to be used in the industry again. So there should not be any water which should go out of the industry. There have been practices in the past where certain amount of water, contaminated water, is directly dumped into the surface water bodies, which is a highly non-negotiable practice now because of the government compliances, government policies. This is not possible, and one should not do that. So this practice of zero liquid discharge is highly recommended for industry to follow. Circular economy is also one concept where you use the raw materials, you design it, you manufacture, you produce something through it, distribute, you can reuse, repair all of those things, collect, and then you have to use it for as long as possible, through which the waste minimization can be obtained, and also the life cycle of the raw material can be improved. So this concept is also applicable to all the industries. It is applicable to water manufacturing. Every industry, this concept has to be implemented. Now, let's understand the reliance of computational physics and AI/ML for this particular industry. And I have a very good example to showcase how smart systems, how computation modeling can be of good use to make it a digital transformation in water industry. Uh, Through AI/ML, there are certain algorithms, for example, random forest, artificial neural network methodology, through which different applications can be fulfilled. If you have abundance of data, the plants, water treatment plants have a good history of data that they are operated on through last 10 years, last 15 years. You just have to organize that data, and you can use it to get more meaningful results. You can get it to better decision making at the end of it. And all the water treatment industries are now equipped with sensors, which are soft sensors, flow meters, temperature meters. All of the your equipments can also be detected by the computer imaging, through which you can predict the life of your equipment. Now you can, through this you can have real time monitoring, and you can have the real time data for any process that you are operating on. Apart from that, you can identify the major source of pollutions. You can also check all the pipelines, pipe network, and local pollutant source point through that. You can also identify the major sources of groundwater pollution, and whatever data you have, you can use it in a more meaningful manner rather than keeping and dumping the data for no use. This example that I'm discussing now is a good example uh, to showcase that how computational modeling can be of help in making the overall process in form of digital or industry 4.0. Earlier people used to note down manually the water metering systems, but now there are water meters which take account for the water footprints digitally, and these water metering systems require a certain laminar flow which has to minimize the turbulence in them, and air entrapment should not be there uh, for correct reading. So there are devices such as flow conditioners used before that, which eventually help you to minimize the turbulence and get the fully developed flow much sooner. So we modeled these systems, and we optimized what will be the optimum design of flow meter through which you can get the fully developed flow much sooner. So this is an example. If you don't use any flow conditioner, you have to use a longer pipeline to get a fully developed flow which will have no air entrapment. But if you use a flow conditioner, you can get the fully developed flow much sooner with minimization of turbulence. So through this animation, you can see one is longer pipeline, one is smaller pipeline where flow meter is used. One is without flow meter, one is with flow meter, and you can see there is no air entrapment in the upper section of the animation, whereas there are gray signs which indicate the existence of air entrapment into the system. So now coming to the last section of the webinar, that is how Pandav can add value to overall water treatment industry. And the answer is that we hold expertise in computational physics, we hold expertise in artificial intelligence, and we provide custom simulation software expertise. That means we can combine physics and AI to give you faster solutions. And that solution starts with, uh, that will be an end to end water treatment computational solution. The problem can be related to flow problem, it can be related to mixing related problem, it can be related to performance of different section of the plant, and it can also be related to hydraulics related problem. You have a solution in form of Pandav application because we hold the subject matter expertise for all of these aspects. Now, there can be potential methodologies which can address the access to clean water, which is seawater to drinking water conversion and moisture to clean water conversion. These are very interesting topics which are highly in focus right now, and some of the companies are also working in these aspects, and this we will cover in the next webinar. Uh, Till then, you can follow Pandav on YouTube, Instagram, Facebook, LinkedIn, or X. And you can reach out to us through support@pandav.com or through our contact number provided here. Uh, and till then, thank you so much. Please stay updated with the content that we roll out. And if in case of any query, you can post in the chat box. Our team will reach out to you and give your answers. And thank you so much for joining